of tan x. So okay, basically in order to approach this, we don't know like how to do this like just in this one piece here. So we're going to go ahead and use our reciprocal identities concept once again. And if you recall, we can write the tangent of x as opposite over adjacent, but also notice that we can divide the numerator and the denominator both by the hypotenuse. So we can say this is the same thing as opposite over hypotenuse divided by adjacent over hypotenuse, because that's like multiplying by 1. It's not going to do anything. But notice the reason we put it in this form, because that's really the same thing as saying the sine of x over cosine of x. So now notice that we just put this in the form of h of x equals some f of x divided by g of x. And well, now we can refer back to, once again, the quotient rule, which said that if we have some d u v dx or u over v dx, meaning we have something that can be expressed in some u of x divided by v of x, still with x as the variable, then we can have this rewritten as, well, it equals v minus du dx minus u dv dx over v squared. If you recall the quotient rule, I did a separate video about that. So okay, so now let's just go ahead and plug the pieces in here. So this would be like saying that sine of x over cosine of x is our u over v. In other words, we're using that sine is our u of x and cosine of x is our v of x. So let's just plug this in. So okay, so we're going to have the derivative of tan x equals, well, with respect to x with the dx part, equals d sine x over cosine x dx. And so now that we have written that up, let's go ahead and figure out what this is. So now this is going to be equal to, first we need our v of x piece. So in this case, that's going to be our cosine of x, and we're going to multiply this by the derivative of u of x with respect to d of x. So we're just going to say u, well, it's u of x prime, so we're going to say whatever d dx times the sine of x is minus our u of x piece, which is the sine, times d dx of our dv dx, so derivative of cosine x. Okay, so this is what we have, and now I can do another video for why this is, but this is very crucial that you know these. So d dx of the sine of x actually equals the cosine of x. I can do a derivation video about this, and also you should know that dx of cosine of x is the negative sign. So these are going to be immensely important that you know these pieces, because they're going to help us to figure out what a lot of different problems on your homework and tests are. So and also we're going to have to divide this by v squared, so divided by cosine of x squared. So now, plugging our pieces in here, we're going to have this equals cosine of x times cosine x minus sine of x times negative sine of x over cosine x squared. So now we're just going to go ahead and combine the top. So notice that there's a minus minus that goes to plus, equals, we'll also notice here that we're going to have cosine of x squared, that's going to go to plus sine of x squared over cosine of x squared. But also, if you recall, we're able to say that cosine of x quantity squared equals cosine squared of x as mathematical convention, and also sine of x squared equals sine squared x. So let's go ahead and put that into the top piece, because that's going to be important for us for what we're going to do next. So equals cosine squared x plus sine squared x divided by cosine squared x. But notice how in the top part here, this should look very familiar to you, because I did a separate video about this. This is one of the common trigonometric identities, if you recall. And so cosine squared x plus sine squared x equals 1. And if you remember that, so let's go ahead and put that in. So this is going to equal 1 divided by cosine squared x, but let's go ahead and expand this now. So this equals 1 over cosine x times 1 over cosine x, because it's cosine x squared. But if you also remember from your other trigonometric reciprocal identities, then you'll remember that 1 over cosine x equals the secant of x. So let's go ahead and plug this in. So this just equals secant of x times secant of x equals secant of x squared, but also notice here this is going to work exactly the same way, where by convention we can say that secant of x squared equals secant squared of x. So now our answer is just going to be secant squared x. So d dx of tan x equals secant squared x. So a lot of textbooks might just tell you that the derivative of tangent is secant squared x without actually showing you why that's the case. So now hopefully this explains that for you. And hopefully you come back for the next one where Joe shows you how.